This is Maximal Rectangle, Leetcode problem number 85, and it is listed as one of Google's top interview questions. So the problem is you're given an array of zeros and ones, and it makes a matrix, and you want to find the largest rectangle that contains only ones. So in example 1, the answer is 6 because these ones here of this row and columns make up a rectangle with 6 units. In the second example, if the matrix is empty, you return 1. If there is no ones in the matrix, in example 3, you return 0. If there is one unit that has 1, you return 1. And that's that. So for this solution, I'm going to use the dynamic programming solution. And so for that, we are going to use 3 arrays. And then for every row, so I'll just put that, using 3 arrays. And each of those arrays will take the optimal index for every row. Capturing optimal index for the left, right, and height. And so we will go calculate area row by row, keep highest area calculated to return. And then to calculate each index, so for every row, for the left index and height index, we are going to go 0 to length of columns. For every row, for the right index, go from length of columns to 0. And then for every row, calculate the area using the best indexes recorded in DP arrays. So that's pretty much our plan. And again, we're going to be going row by row. So first, let's take care of the edge case of if there's nothing in the matrix. So if the matrix equals 0, return 0. Then let's make our DP arrays. We're going to make one for the left, and that's going to be the column length. We're going to make one for the right, the same length, the column length. And we're going to make one for the height also. And for the right away, we are going to record the minimal value between the current index we're on and the DP array that we have currently. So we're going to fill that in with the length of the columns to start off with. So we're filling the right array with the matrix 0 length. And this is what we're going to be returning. We're going to be returning the max area, and it's going to start off at 0. So again, for every row, that is going to be, for our index I equals 0, I length less than the rows length, I plus plus. So for every row, we're going to have a current index. So we're going to have a current left index that is going to start off at 0, and we're going to have a current right index that is going to start off at the column length. And let's go from left to right. J less than the column length. Okay, so we're at this specific row and column, and we're going to say if we're at a 1, so at this row and at this column, if it is equal to 1, we are going to take whatever height we have, and we're going to say, okay, we're going to add 1 to this because we know that the height is going to be 1 plus the height that we have now. So when you initialize an array, they all have zeros. So for instance, on this first one, it's going to be 1. So when we do length times width times height, it's going to be, the height is going to be times 1. And we're going to make our DP array of J to going to be what is bigger, our current left or left J and then, okay, if we hit a 0, our height is going to be 0. The current left is going to be J plus 1, and the DP for the left here is going to be 0. Okay, and then we are going to, from right to left, so let's go from right to left. And J equals because it's 0 base, it's going to be the length minus 1, while J is greater than or equal to 0. And then we're going to do J minus minus, so we're going from right to left. And it's going to have a similar logic to it as we did for the left index, except we're going to be recording the min. So that's if it's 1, and if it's not 1, we are going to make our current right equal to j, and our right j, our dp is going to be so let's go and find the max area for this row that can be calculated. And let's say our max area is going to be equal to the max of whatever the max area is now, and or we're going to calculate our area, which is going to be our dp array of our right minus the dp array of our left. So that's going to be our length, and it's going to be multiplied by our height. And after that, we should just be able to return our max area. Just want to get as most I can in the visible screen. Let's try to run this. That works. And let's see if this works. It does. But what we can do is do a printout of all of the indexes for the DP array at every row. So let's see. We can print, this is height, DP, and then we'll get this will be left index. So this will print out what the DP is as we're calculating it, and then we can print out the right one. Put it right here. And then we'll print out the area as we calculate it. So this will be every max area as it's calculated per row. And we're going to do max area. Let's run the code. So as you could see, height is 1, and the left index is 0, height DP is 0. This is all calculated. Let me do let's do a line break. Let's do 2 line breaks between there. Okay, so then we could see after every row, we have the dp of the height. It'll go 1, then it'll be 0, then it'll be 1, 0, 0. And then the right dp will be index 0, 1, 2, 3. It'll be the length, and then it'll change to 3, 0, 1, 2, 3 as it turns to 0. And then we calculate our max area as 1, and max area is 1 because it's just one block here and one block here. Max area is 1, max area is 1. That's for every, so for every box we'll count it, the max area will be 1, it'll be 1, it'll be 1, it'll be 1. So for every box for every column in the first row, the max area is 1. And then we're going to go into our second row. The height is 2, left index is 0, height is 0, etc. So then when we get to the end of the row, we'll do the max area. It's going to be 2. It'll stay at 2 until it gets here when it's 3. And then so on. This shows you all of it, and then how eventually it gets to 6. And once the max area is 6, it'll stay at 6. So it'll no longer calculate it here to be anything but 6. And then that's the output. And that's that. So, okay, thank you.